In the previous videos discussing enthalpy, we went over various ways to calculate how much heat or how much energy is released or absorbed in a particular reaction. And now we can use the same principles we had in previous chapters of our books to look at reaction stoichiometry and how that relates to enthalpy. So here we have a reaction which is methanol in the gaseous phase, giving us carbon monoxide gas plus 2 hydrogen gas. And the delta H for this particular reaction is positive 90.7 kilojoules. So now the question we're asked is how many kilojoules of heat are either released or absorbed when 32.0 grams of carbon monoxide reacts completely with hydrogen gas. So we need to express this reaction, and that's going to be CO gas plus 2 hydrogen gas, giving us CH3OH as a gas. And the delta H for this reaction is going to be negative 90.7 kilojoules, because we can use our properties of delta H and energy to determine the delta H for the reverse reaction that we had been given. So then we can take our 32.0 grams of CO. Using the periodic table, 1 mole of CO is going to be 28.0 grams times negative 90.7 kilojoules of energy are going to be liberated when 1 mole of CO reacts. So this is going to give us negative 103.66 kilojoules, or if we go to 3 significant figures, negative 104 kilojoules of energy. And this is going to be energy, since we have a negative sign, that's released. So negative or 104 kilojoules of energy is released when 32.0 grams of carbon monoxide reacts completely with hydrogen gas. We can also ask and do a similar example problem when we asked if 2.4 grams of magnesium solid reacts with 5.7 grams of oxygen gas, how much heat is produced? So in this particular case, we need to have the overall balanced equation, and that is 2 magnesium solid plus O2 gas, giving us 2 MgO solid. The delta H for this particular reaction is negative 1204 kilojoules. The thing that we have to look at now is we have to look at this problem in terms of a limiting reactant. So if we have 2.4 grams of magnesium, and we use our conversion factors, that 1 mole of magnesium is 24.3 grams. And we know that for every 2 moles of magnesium, we're going to get negative 1204 kilojoules of energy. So when we do our conversion factor here, we get negative 59.46 kilojoules. Or to 2 significant figures, we get negative 59 kilojoules. Okay? That's if all of the magnesium reacts, and if the magnesium was the limiting reactant. So now we need to take our 5.7 grams of O2 and perform the calculation as if the oxygen was the limiting reactant. So for every 1 mole of O2, we have 32.0 grams, and we know that for every 1 mole of O2 that reacts, we get negative 1204 kilojoules of energy. This gives us negative 214 kilojoules. So if we're comparing here, the 59 negative 59 kilojoules is the smaller number. That tells us that the magnesium solid is the limiting reactant. And if the magnesium is the limiting reactant, this tells us that 59 kilojoules of heat is produced. So we can look at these problems, do calculations just like we did for reaction stoichiometry, and we can actually use limiting reactant type reactions to figure out exactly how much heat is going to be produced or absorbed in a particular chemical reaction.